Hello students, welcome to the class. So in the previous class, we had discussed some questions, some set of questions. Now moving to another set of questions. Yes, so here we have 47th question. The question is the correct geometry and hybridization for XEF4 is. So XEF4, how do we write it? They've asked the geometry hybridization. So XEF4. Okay, so H is equal to half valence electrons 8 minus it is single bonded to 4 plus 8 minus 0 plus 0. So 8 plus 4 is 12. So it is 6. H is equal to 6 means what? The hybridization is sp3d2. 3, 4, 5, 6. So hybridization is sp3d2. For sp3d2, the geometry is what? For sp3d2 hybridization, the geometry is actually octahedral geometry. But here, since it is having lone pairs, the geometry comes out 2. It comes out something like this. Yes, so the geometry comes out. Here is Xe, which is bonded to 4 fluorine atoms, monovalent atoms. So F, 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 and F, and here above there is one lone pair and below there is one lone pair. Yes, so this is the geometry which is called as octahedral geometry. It is called as octahedral geometry. Shape is square planar. They have asked geometry, so geometry is octahedral. What is the shape? The shape is square planar. It seems to be square planar. Yes. So what is the correct answer? Option A, octahedral geometry and sp3d2 hybridization. Among the following, which one is a wrong statement? PH5 and BiCl5 do not exist. P pi D pi bonds are present in SO2. SeF4 and CH4 have same shape. I3 plus has bent geometry. PH5 and BiCl5 do not exist. That is true because bismuth it shows +4 oxidation state, so it is BiCl4 should come. Phosphorus cannot combine with hydrogen because this becomes a very very violent reaction. P pi D pi bond are present in SO2. Yes, p pi d pi bonding is present in SO2. That means the pi bond is formed between p orbitals of sulfur and d orbitals of oxygen, like that. SeF4 and CH4 have same shape. Yes, there is something going wrong here. SeF4 and CH4. We know that CH4, it is having tetrahedral geometry. It has tetrahedral geometry like this, correct? H, 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 H. So this is tetrahedral geometry because the hybridization is sp3. What about SeF4? Yes, looking at this molecular, immediately looking at the molecular formula, we cannot come to the conclusion. Oxygen, sulfur, selenium. Selenium belongs to oxygen group. Okay, so half, there is sulfur, oxygen means 6 electrons and it is bonded to 4 fluorine atoms minus 0 plus 0. 6 plus 4 is 10, 2 5s are 10. Therefore, H is equal to 5 means what? The hybridization is sp3 dehybridization. For sp3 dehybridization, there are 2 bonds which are like this, F and F with fluorine, and 2 bonds are here. So fluorine, fluorine, and here there is one lone pairs of electrons. So the geometry is seesaw shape. The geometry is seesaw shape. This geometry is tetrahedral. So both of them do not have the same geometry. So that is the wrong option. So SeF4 and CH4 have same shape. That is wrong. I3 plus has bent geometry. Yes, it is having bent geometry. Moving to the next question. In which of the following pairs both species are not isostructural? Yes, okay. Diamond, silicon carbide, NH3, PH3, XeF4, XeO4, SiCl4, PCl4. See, in diamond and silicon carbide, what is silicon carbide? Silicon carbide is SiC, which is also called carborundum. So in diamond and silicon carbide, central atom is sp3 hybridized. Hence, both are isostructural. Both have tetrahedral geometry. In case of NH3 and PH3, both are pyramidal. Pyramidal. Yes, both are having sp3 hybridization only, but here along with bond pairs there is one lone pair on nitrogen and fluorine, phosphorus. Therefore, it is a distorted geometry, that is pyramidal geometry. SiCl4 and PCl4 plus, if you see, they are also tetrahedral. They are also tetrahedral because in these cases the geometry is, the hybridization is sp3. You can work it out and see. It is sp3. Xc, in case of XeF4 and XeO4, if you see in case of XeF4, XeF4 just now we have seen hybridization is sp3d2. So 6 it comes value. Hybridization sp3d2. So structure is square planar. Square planar. Yes. Whereas in case of XeO4, our xenon is sp3 hybridized. For example, 8 plus oxygen, there are valence electrons. So it is bonded to 4 oxygen atoms. All 4 are triple bond. So I will show you the structure of XeF4. XeF4 structure is this: F, F, and F, and F. Yes, and here there is one lone pair, here there is another lone pair. Whereas XeO4, all are double bonded to oxygen atoms. All bonds are double bonds. So it is 8. So 8 minus 8 plus 0. So 2 4s are 8. So 4 means hybridization is sp3. Yes, and the structure of the molecule is tetrahedral. The structure of the molecule is tetrahedral. So where it is not isostructural, it is not isostructural in this case. Yes. Maximum bond angle at nitrogen is present in which of the following? NO2 plus, NO3 minus, NO2 and NO2 minus. So where maximum bond angle is present? So if you consider the species, let me say I have species here. Yes, then we will see hybridization and then we can discuss about the bond angles, because if we know the hybridization, we can speak about bond angles. The species are, they have given NO3 minus is there. Then we have NO2. Then we have NO2 minus. And then we have NO2 plus. Okay. So if you look at the hybridization, H is equal to half. Valence electrons, nitrogen are 5 plus it is bonded to oxygen atom. So how much will, with what bonds? So 5 plus, there is one single bond, minus 0 plus 1. Yes, so there are 2 single bonds. So 5 plus 2 is 7. Sorry, there are 3. 5 plus 3 is 8. Yes, 5 plus 2 is 7. Single bonds are 2. Minus 1 is 6. So 2 ones are, 2 threes are. If it is 3, hybridization is what? It is sp2. Like that, if you do for NO2, you will get hybridization sp2. For NO2 minus also hybridization is sp2. But for NO2 plus, it is sp. It is sp hybridization. Okay. So what will be the bond angle for sp2? 120 degrees. For sp2, 120 degrees. For sp2, 120 degrees. And for sp, it is 180 degrees. We expect this. But actually for NO2, since there are lone pairs, the bond angle is not 120 here. The bond angle is not 120 here. It is 134 degrees. It becomes more. In case of NO2 minus, it is not 120. It becomes 115 degrees due to lone pair repulsions. And here it is 180 degrees only. So which one is having maximum bond angle? Where there is maximum bond angle, it is for NO2 plus. It is for NO2 plus. Yes, therefore NO2 plus has got option A. NO2 plus has maximum bond angle. It has got maximum bond angle. Which one of the following species has planar triangular shape? Planar and triangular shape. N3, NO3 minus, NO2 minus, CO2. We have CO2 is linear. Yes, this is bent shape. They have asking planar triangular. It is for NO3 minus. I will show you. Nitrogen, it is double bonded to oxygen. One is coordinate bond and another one is single bond. Okay, single bond. So if you see balance the electrons, we have minus charge here. Here there are 2 lone pairs of electrons, and here again there are 6, that is 3 lone pairs of electrons. So why this structure comes is, it is because of sp2 hybridization. And because of sp2 hybridization, the geometry is diagonal planar, which is also called as triangular shape. Next question, XeF2 is isostructural with. Okay, what is the geometry of XeF2? If I ask you, what is the geometry of XeF2? XeF2. Yes, this is XeF2. So it is having 3 lone pairs. The hybridization of XeF2 is sp3d, and the geometry is linear. Yes, so they have given us 4 options. SbCl3. SbCl3, if I want to write Sb, that is antimony, then here we have electrons, chlorine, chlorine, chlorine. The hybridization of this is sp3, but the geometry is pyramidal due to presence of lone pair. Correct? Okay. Next option is BaCl2. We know BaCl2, barium chloride. It is BaClCl. Yes. So we get it like this. Then we have tellurium fluoride. The tellurium fluoride, it is structure is Te. Here we have fluorine, here we have fluorine, and tellurium is having 2 lone pairs. Hybridization is sp3 with a V-shaped or bent shape, we say shape. Okay. Then we have another option is ICl2 minus. ICl2 minus. The hybridization here is sp3d. So sp3d hybridization means what? The geometry will be linear. You can see here ICl, iodine is having 3 lone pairs here. Therefore, the geometry is linear. Yes. So this is about which one is the correct option. The correct option is ICl2 minus. It is ICl2 minus. Which of the following is a polar molecule? Okay, SiF4, XeF4, BF3, and SF4. If you want to speak about polarity, the degree of polarity is what? Dipole moment. You should be knowing dipole moment. SF4 option D, if you see, it is having sp3d hybridization and shape is seesaw. We have seen in one of our examples. Yes. So there are 4 bond pairs and there is 1 lone pair on oxygen sulfur atom. Therefore, the structure is, it is something like this. Fluorine, 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 fluorine. And there is 1 lone pair. Correct? There is 1 lone pair. Yes. What will be the resultant dipole? This is in opposite directions. This is in opposite. So resultant dipole will cancel out. Will it cancel out? No. It will have some net resultant dipole and therefore mu is not equal to 0. In all the other cases, if you see SiF4, they will cancel out because silicon is not having any lone pairs. XeF4, the 4 bond pairs will cancel out with 2 lone pairs on xenon. BF3, it will cancel out. But in SF4, mu is not equal to 0. Therefore, I can say it is a polar molecule. The outer orbitals of carbon in ethene molecule can be considered to be hybridized to give 3 equivalent sp2 orbitals. The total number of sigma bonds and pi bonds in ethene molecule. Okay, ethene molecule they have said. So ethene is what? Ethene is an organic compound which is a hydrocarbon containing 2 carbon atoms and 4 hydrogens. So carbon, there is a double bond and each carbon is bonded to 2 hydrogens. So we are going to see how many sigma bonds. 1, 2, 3, 4. In a double bond, 1 will be sigma, 1 will be pi. So totally there are 5 sigma bonds and there is 1 pi bond. Yes, so it contains 5 sigma bonds and 1 pi bonds, which is our correct option. 5 sigma bonds and 1 pi bond. C option is correct. C is the correct option. Okay. In which of the following pairs both the species have sp3 hybridization? SiF4BeH2. Take the species, find the hybridization. First option, SiF4BeH2. Okay, so H is equal to half. Valence electrons on silicon are 4. It is bonded to 4. There is no charge. So 4 plus 4 is 8. 8 by 2 is 4. So 4 means what? sp3 hybridization. BeH2, half. Beryllium, it is valence electrons are 2. It is bonded to 2. So 2 plus 2 is 4. It is 2. sp2. Okay, this is first option. Second option, NF3H2O. Half nitrogen 5 plus 3. 5 plus 3 is 8. 8 by 2 is 4. So it is sp3 hybridized. H2O, half oxygen. Central atom is oxygen. 6 plus 2. It is 8. 8 by 2 is 4. sp3 hybridization. Third option, NF3BF3. So NF3 just now we have seen it is sp3. BF3, half. 3 valence electrons plus 3. 6 by 3 6 by 2 is 3, so it is sp2. Last option, H2S and BF3. Just now we have seen BF3 is sp2 hybridized. H2S, sulfur, half. 6 plus 2. 6 plus 2 is 8. 8 by 2 is 4. So it is sp3. So where they have same sp3 hybridization, it is option 2. NF3 and H2O. NF3 and H2O. So option C is the NF3 and H2O. Option B is the correct option. Correct? Which of the following pairs is isostructural, having same shape and hybridization? Once again, we are going to verify all of them. Yes, these are like your revision questions, you can say. Yes, we'll be repeating all the questions again and again. First option, BCl3 and BrCl3. Work out half V plus M. Yes, if you work out like that, here BCl3 is sp2 hybridized, BrCl3 is sp3 dehybridized. Okay, so the geometry is trigonal planar, and here the geometry is T shape. Second option is NH3 and NO3 minus. We have seen this many times. NH3 is sp3, NO3 minus is sp2. NH3 geometry is pyramidal and NO3 minus is trigonal planar. Third option, it is NF3 and BF3. Correct? NF3 hybridization is sp3 and BF3 hybridization is sp2. Here also it is pyramidal and this is trigonal planar. Last option, BF4 minus. BF4 minus, you can see half. Boron is 3 plus 4 minus 1. 3 plus 4 is 7. 7 minus 1 is 6. So 6 divided by 3. Boron is outermost shell 3. It is bonded to 4. So minus 1 cation charge. So minus becomes plus. 7 plus 1 is 8. 8 by 2 is 4. So hybridization is sp3. Geometry is tetrahedral. Then which one is given? NH4 plus. We have seen this sp3 geometry is tetrahedral. So hybridization and geometry is same for option 4. It is same for option 4. BF4 minus and NH4 plus. So option D is the correct option. Correct? Next question. Which of the two ions from the list given below that have geometry that is explained by the same hybridization of the orbitals. NO2 minus, NO3 minus, NH2 minus, NH4 plus, SCN. Here only we can see. So many we have done. So NO2 minus, it is having sp2 hybridization. NO3 minus is also having sp2 hybridization. NH2 minus is sp3 and NH4 plus is also sp3. Whereas SCN is sp. So which pairs are having same hybridization? NO2 minus, NO3 minus, NO2 minus and NO3. Yes, both are sp hybridization, sp2 hybridizations. NH4 plus, NO3 minus. No, this is sp3, this is sp2. This is sp and this is sp3. This is sp2 and this is sp3. So it is option A which is correct. They have same hybridization of the orbitals. Correct? Next question. In which of the following pairs of molecules or ions the central atom has sp2 hybridization? Where hybridization is sp2. NO2 minus, just now we have seen it is sp2. NH3 is what? NH3 is sp3. Correct? BF3 we have seen. Yes, BF3 boron trifluoride. You can calculate BF3 is equal to half boron. There are 3 electrons plus 3. There is nothing, 0. 6 by 2 is 3. So it is sp2. Correct? Hybridization. And for NO2 minus, H is equal to half. There are 5 electrons plus both the bonds are double. Therefore, I will take 0. Minus 0 plus 1. So 5. So 5 minus 1 is 4. 5 plus 1 is 6. 6 by, so 0, 0 gets cancelled. 6 by 2 is 3. Again, the hybridization is sp2. Correct? So hybridization is sp2. Getting? So BF3 and NO2 minus, they are having sp2 hybridization. They are having sp2 hybridization. In which of the following species the central atom has the type of hybridization which is not the same as that present in other threes? Okay, so option is SF4, I minus 3, SbCl5 minus 2 and PCl5. So you can calculate the hybridization using formula H is equal to half V plus M minus C plus A. When you apply that formula, we will find that all the given species, SF4, I3 minus PCl5, they have the central atom with the hybridization sp3d. All of them will have sp3d. This and this. But SbCl5 minus 2, SbCl5 minus 2 is what? It is sp3d2 hybridized. It is sp3d2 hybridized. So these three are sp3d and this is sp3d2. Yes, so therefore this is different. It is different. In which of the following molecules the central atom does not have sp3 hybridization? So CH4, SF4, then BF4 minus, and then they have given NH4 plus. Please do remember, for neutral atoms, number of electron pairs will be equal to number of atoms bonded to it. Yes, I'll tell you like this. Number of electron pairs will be equal to number of atoms bonded to it plus half group number of central atom minus valency of that central atom. Valency of that central atom. So if you take for CH4, number of electron pairs will be equal to what? Number of atoms bonded to it. How many atoms are bonded to it? 4. Plus half group number of that is what? of central atom. Which is the central atom? It is carbon. So group number for carbon is what? 14. So 4 valence electrons minus 4. Yes. So 10 minus group number. 10 minus group number of the valence central atom. Okay. So how much you get? 4 plus half, 4 minus 4. So we get answer 4. What is the hybridization? sp3. Yes, you can do it directly also. H is equal to half V plus M minus 0 plus 0. You can use like this also. So we'll get it the same. Similarly, do it for ions. If you take BF4 minus, let us verify here only, BF4 minus, half, valence electrons are 3, single bonded are 4, cation 0, anion plus 1, correct? 7 plus 1 is 8, 8 by 2, 4. So it is sp3 hybridization, BF4, correct. For NH4 plus also, it is sp3 hybridization. We have done it many times. Whereas SF4, we know that. What is the hybridization of SF4? The hybridization of SCF4, half, sulfur is having 6 plus 4 minus 0. So 10 by 2, 5. So it is sp3d. The hybridization for SF4 is sp3d. Rather than going for that, you can use the direct formula. Or I had told you one more. Okay, it is different for SF4. Some of the properties of two species, NO3 minus and H3O plus, are described below. Which of them is correct? Dissimilar in hybridization for the central atom with different structures. Isostructural with same hybridization for some central atom. Isostructural with different hybridization for central atom. Similar hybridization for central atom with different structures. If you look at the hybridization of given atoms, given molecules, for NO3 minus, yes, H answer comes out to half 5. So 5 plus how much oxygen it is bonded? 1 single bonded minus 0 plus 1. So it is not bonded to any, all are double bonds. 5 plus 1 is 6. 6 by 2 is 3. So it is 3. So what is hybridization? It is sp2. Correct? For H3O plus, half, oxygen, valence electrons are 6 plus how many it is bonded? 3 hydrogens minus 1 plus 0. Yes, so 6 plus 3 is 9. 9 minus 1 is 8. 8 by 2 is 4. Hybridization is sp3. Getting my point? So what is correct here? Though hybridization is sp2, hybridization is sp2 for NO3 minus and hybridization for H3O plus is sp3. So there is a difference in hybridization for the central atom. When hybridization is different, the structure will be different. So hybridization is also different, structure is also different. So dissimilar in hybridization for the central atom and with different structures is the correct option. Yes, next question. In which of the following molecules or ions, BF3, NO2 minus, NH2 minus, H2O, the central atom is sp2 hybridized? Central atom is sp2 hybridized. So if you consider BF3, we know that it is sp2. NO2 minus, they are saying, that is NO2 minus, it is also sp2. NH2 minus, we have seen it is sp3. And H2O is also sp3. So where it is sp2 hybridized, BF3 and NO2 minus. So option C is the correct option. Rest all we know. We have already seen so many times this question. Yes, in different way. This is asked in different way where sp2 hybridization is there. Okay. Then in which of the following pairs the two species are isostructural? Yes, where hybridization is same, that will be isostructural. Yes, you can work out for all the given pairs. But I will tell you in Br O3 minus and XeO3 molecules. The hybridization H, if you calculate, it comes out to, for BrO3, half bromine 7 plus all are double bonded, therefore I'll take 0 minus 0 plus 1. So 7 plus 1 is 8, equal to 4. So hybridization is sp3. For XeO3, it is H is equal to half 8, all are double bonds, plus 0 minus 0 minus 0, it also comes out to 4. Hybridization is again sp3. Yes. So for these two, you can check it for all of the others also. We have done it so many times. SO3 minus 2, NO3 minus, we have done. Yes. So it will come, hybridization comes out same for BrO3 minus and XeO3. The central atom is sp3 hybridized and contain one lone pair of electrons. So I'll show you the structure. Br, yes, two oxygen atoms. There is double bond oxygen, and here there is oxygen with negative charge, and there is a lone pair of electron. And if you consider xenon, double bond O, double bond O, double bond O, and again a lone pair of electrons. So these are the structures. So both have trigonal pyramidal geometry. Both of them have trigonal pyramidal geometry. So what is being asked? Two species are isostructural. So it is option C, BrO3 minus and XeO3. Both have got same structure, that is trigonal pyramidal, because of similar hybridization sp3. Yes, that is distorted geometry we call. Yes. Next, which of the following species has linear shape? Linear shape means the bond angle comes out to 180 degrees. So let us see given options. O3 molecule. First option is O3. O3 molecule, we have seen the structure. It is like this, correct? It is what? Bent shape or inverted V. Inverted V shape. The bond angle comes out to here 116.8 degrees for O3 molecule. Second option is NO2 minus. For NO2 minus, the structure is oxygen negative charge. Here double bond O. Yes, and there is lone pair on this nitrogen. The bond angle here is 115 degrees. Yes, the bond angle is 115 degrees. Yes, okay. Next option is SO2. For SO2, due to the presence of one lone pair on sulfur, in one of the three sp2 hybrid orbitals, SO2 molecule has angular shape, or you can call it as inverted V again. Okay, so the bond angle here comes out to 119.5 degrees. 119.5 degrees. Last